Hi, thanks for coming, everyone. So it was Christopher Ireland who actually turned me on to Kevin's work. I was doing some research last year on tracking identity in the digital realm, and she sent me to this site, a blog called The Quantified Self, and it's a blog where people are posting all sorts of self-tracking methods, like mood, sleeping patterns, diet, exercise. I think yesterday someone had posted a graph on how long it took him to type to answer a simple math problem. So like really geeky stuff, but I loved it. And then there's another section on his site called Cool Tools, where every weekday he's posting the best, cheapest tools available, like gadgets, websites, books, anything that's just cool. And then I found this book called Out of Control. And the quote was, "The most potent force in technology will be artificial evolution." So like robots. I was like, okay, sweet. So I bought all the books. And then I came upon a section called the Technium, and I was like, what is that? I was like, this guy started Wired, gadgets, cool tools, it's got to be something awesome. So you're going to hear about the Technium in a second. That turns out to be the thesis of this book. But let me start by saying who Kevin Kelly is. In the 70s, he left college to spend 10 years walking all over Southeast Asia as a photographer. And all those photos are in a book called Asia Grace. He's biked 5,000 miles across America twice. He's walked most of the Appalachian Trail. In 1984 to 1990, he co-edited the Coevolution Quarterly, which is now called the Whole Earth Review. 1989, he designed Cyberthon, which is a 24-hour marathon where 400 guests were invited to try out the latest in virtual reality prototypes. He's a board member of the Long Now Foundation, which is building the 10,000-year clock, which is going to be installed on a mountain in Nevada. And he co-founded Wired magazine until in 1993, where he served as executive editor until 1999, and now he's senior maverick. He also co-founded the All Species Foundation, where he attempted to catalog and identify every living species on the face of the earth. So pretty bold stuff. He's also co-author of Out of Control, which I just mentioned, which was one of the books that Keanu Reeves and Lawrence Fishburne were asked to read before they could even open the script. And New Rules for the New Economy, which he poses 10 radical ideas on how to deal with a networked economy driven by communication and intangibles such as information, entertainment, copyright, and securities. And now he's got what technology wants. So at the design program at CCA, we're constantly trying to think of the next best thing. We, through design research, we look at history and trends and patterns, and we try to make sense of the world around us and design our own solutions for the future. And this is the type of methodology that he's applied to his design problem of what exactly is technology and what does it ultimately want. So I give you a futurist, techno vanguard, and one of the most provocative thinkers of our time, Mr. Kevin Kelly.
There's a note here that says food after. Okay. I don't know if that's for me or for you guys. Thank you for inviting me here. Actually, I'm full of regret because this is my first visit, and I realize, oh my gosh, there's incredible amount of great things being done, people making things, which I really love. And I'm honored to be here. And after that introduction, I feel terribly intimidated because I'm not sure I'm going to be able to live up to all that. It's really fantastic to be around people who approach the world as with solutions, which I think is what design does, is you bring solutions to things. And so I wanted to, though, take this time to step back and maybe put what we all do into a little bit larger context, because we oftentimes can get wrapped up in day-to-day problems of making solutions. And so at times we should take the longer view, and that's what I want to do. As Phil mentioned, I've written this book called What Technology Wants, and it's an attempt really to give us a framework for this. All of us, probably everybody here in some degree in the future, will be involved in creating new things for most of the rest of your life. And as we do that, we don't really have a very good framework for understanding that. It reminds me of a time, excuse me, of biology before Darwin. What Darwin was confronted was the world of the natural world, and there was, hundreds and thousands of naturalists, and what they did was they collected stuff that they would display in these kind of frames. And the reason is because in that time, before the theory of evolution, biology was just one thing after another. And that's what it was. And so they kind of put them up in these frames. There was no organization. There was just collecting stuff. And in some ways, our world right now, as we invent new things and as we consume new things as they come along, as we market them, technology is in a similar kind of state because there's really no theory. What it really is one thing after another. That's our theory. Our theory of technology is what's one thing after another. And I'm suggesting that I think, in fact, there's more to it, that we might have a better frame, a better outline of what's going on, and that if we did, we might be able to better prepare for it, and more importantly, better understand it and use it better. So what I'm going to do in some kind of a rough sense is actually not very, I have only a very kind of narrow aim this evening, which is kind of to present a very rough idea of what a theory of technology might be. And I'll try to focus on that. So I really want to not speak too long, just kind of give you the highlights, and then really open up to questions and answers and dialogue. And I'd be happy to answer things other than what's in the book. We can talk about the future of media. We can talk about Wired. We can talk about my travels in Asia. It doesn't really matter. But I like to have a conversation with understanding what it is that we're doing in the larger context. It's not just one thing after another. It's more than that. It is, in fact, I think, some kind of, well, here's a definition of technology. That's what we think technology is, or else it's this one. It's anything that doesn't work yet. That's more like it. But obviously, technology has to be more than that. I mean, the concrete here, the lights, the conduits, the ductwork, all these things are obviously technology, the things we don't even think about, the asphalt outside, the trucks, the drainage systems, and more importantly, the intangible stuff, the things that we can't even see, like our laws, calendars, double entry bookkeeping. These concepts and techniques and methods are also as much of a technology as anything that's hard, and they've all been around, and they're kind of invisible to us now, but that's actually most of what technology is. Excuse me, but actually, I think it's even more than just all these things together, and that's my point, which is that if you take these two technologies, these two artifacts, excuse me, the one on the left, a Neolithic stone axe, any one of us here with some effort could make, something about the same size and shape, the mouse, nobody here could make, even with a full year of work. In fact, all of us here, no matter, despite how smart everybody is, not all of us here could not make this thing. And that's because it requires hundreds of other technologies to be created to create and manufacture and support it. And each of those technologies, sub-technologies, have technologies below it which are required to create it and make it. And so in a certain sense, we should really think of that thing as a networked artifact or a ecosystem of technologies. And every artifact today has an ecosystem of technologies surrounding it that are necessary to be there, kind of like a guild in ecology. There is a suite of technologies that are required to keep anything alive or to even to produce it. And there are overlapping, because the network that makes this would overlap with the network to make a computer, which would overlap with the network to make the iPhone. And what I am interested in, most interested in, is the larger mega network, this sort of super ecosystem of all these technologies together that we have made so far, the ways in which every bit of thing that we make is in some ways codependent on these other technologies in the world. And that larger super ecosystem, maybe I would call it a super organism of technologies, is something I call the technium. And the technium, I use that word to indicate that it is more than just a bunch of one things after another. It's more than just a collection of things. It actually represents the fact that this is a system, that all these subcomponents are highly coupled and highly dependent upon each other, so that the whole thing forms a system. And as we know from system studies, any system, whether it's artificial or natural, exhibits certain biases, certain tendencies, certain inherencies, certain trajectories, certain urges, drifts, certain agencies. And my question is going to be, if this is a technium, if this is a superorganism of everything we've made, what are the inherent tendencies in this system? And I'm going to try to answer that. And the way I begin is by thinking about, I use the word want. So I say, what does the technium want? And I want to be clear that when I say that, I'm using the word want to mean a drift, an urgency, a tendency, and not to mean something conscious, not to mean something deliberately intelligent, but something that emerges out of the system in a non-personal way, in the way that this can, there's a robot there that been invented down at Stanford. Willow Garage is the name of the company. It's, I think it's called a PD2, and it's been programmed to recharge itself, to recharge its own batteries. And it does that by wandering around through the building looking for electrical outlets. It has 9 eyes, and it can recognize that, and it is mobile enough with its arm to reach behind and get its tail, which is a plug-in cord, and to plug itself in with the plug and be fed. And I stood between it and one of those plugs, and I could feel that it really wanted this juice. I mean, it was trying to get around me. I could feel that its want. Now, it was not conscious. It was not deliberate. It's a system that has a need, has an urge towards this. And so I'm using that word in the same way of what's the tendency, what's the drift, what's the bias in the technium, technology as a whole, in this direction. And I'm using it in the same way that plants might want light. Okay, so they're kind of programmed to go in that direction, and even though they're not conscious of it. So I think the real place that I would start is by saying that, or I should say, I'm going to start where I'm going to end where I start, and that is that the conclusion is that technology as a system exhibits its own agenda, and so it's selfish in a certain way. The little bit of autonomy that it has, and we don't know how much it has, but the little bit of autonomy that it has means it has its own agenda to some extent. That's the bad news. It's selfish. The good news is that this agenda, this direction that it has, is actually a positive direction. So it actually adds a kind of a moral vector to technology in the positive direction. So that's the good news. Bad news is that it has its own agenda. The good news is that its agenda is basically aligned with good stuff. So let me tell you how I got there. I think the place to begin was this amazing discovery 50 years ago that the essence of life was not energy, it was not carbon, it was not tissue, it was actually information. 50 years ago or so, when we discovered, actually 60 years ago, when we discovered that the genetic code was kind of a binary code, that in fact the thing running through life and running through evolution, the thing that was animating it, giving it its power, was actually information. And of course, technology is that. That's what we do with design. That's what design is. Design is infusing material goods with information in order, rearranging those atoms in ways that add intelligence to it. And so the things that we make in the mechanical world are basically infused and made interesting and powerful with information, just as life itself was is propelled by information. And so that suggests that there's actually a continuum, at least, and maybe some equivalency at best, between the world of the born and the world of the made, between living things and manufactured things. That they're not separate as we think, that there is a greater overlap between them, and that we can understand, again, that the, excuse me, the important things in life come through this flow of information. And the same is true of the mechanical world. This is the flow of information. And so therefore, we have some basis to look at evolution for a solution to understanding what technology wants. And that's what I'm going to do. I'm going to go back and say, what does evolution want? What is the force propelling life? And if that's really a continuum into technology, then we can understand a lot about technology by looking at evolution. One of the first things we see about what evolution wants is that it wants increasing diversity. We see that across many, many different taxon in biology, in nature, that on average, things tend to become more diverse over time. We see other things. The larger story that's kind of evident to most people is that there is increasing complexity. So the story of life is that it goes from the few to the many. It goes from the simple to the complex. And what I want to say about that journey, where the first life is very simple and the later life is more complex, is that two things. One is that this is not a destiny. This is not to suggest that evolution is climbing the ladder, and so that at the beginning there's the bacteria, and at the end there's humans, and that we are sort of the climax or the omega point or the destiny in some ways of evolution. It's only to suggest that that there's an arc in the travel. There's a way in which, in fact, every living organism on Earth today, and despite my attempt to try to initiate a catalog of all the living species, we haven't succeeded. We've only identified maybe 5% of the total number of species on Earth today. We don't even have a good estimate of how many there are, but there's probably more than 3 million, and there's maybe 30 million. But every one of those 30 million species alive on Earth today are all equally evolved. The horseshoe crab and the cockroach and the starfish and the giraffe and us are all equally evolved. We've all been around for 3.7 billion years. Each one of these species has accumulated 3.7 billion years of learning, have it compressed into their genes. And so everything is highly evolved. Everything on Earth is equally highly evolved. They're not highly as complex, but they're all highly as evolved. And so that evolution and increasing complexity is not to indicate that this is a ladder. What we have, in fact, is something that looks more like a radiation outward. That this is actually a direction and not a destiny. This is something where all species are evolving, and they're all in some way increasing in these vectors, but there is no final destination. There's only different directions. So the other things that we see evolution moving towards is greater complexity, as I said, greater diversity, greater specialization. The first cells were general purpose. The first organisms had all the same cells. There was one cell used for everything. Later on, they evolved the specialized cell, a neuron, which allowed these cells to communicate. That communication exploded the possible forms that life could be. Suddenly you could have ferns and starfish and seahorses and everything else possible because the neurons allowed communication. That specialized cell increased along with diversity. And we saw specialization increase, so that even in our own bodies, we have 250 specialized cell types. So generally, over the long term, there's increased specialization. So it moves from the general to the specific. We see mutualism. Half of the living species on Earth are parasitic or symbiotic. They're deeply dependent, co-entwined with other living species, either alike or unlike, but they form very, very strong bonds, and they need other species. We also see increased socialization, like among insects, where they depend and form larger social groups. Animals, and even in plants, are very socialized and increasing their socialization. So that's a general trend. Over time, evolution moves towards more of these things, including sentience. Evolution keeps making and inventing little brains, all different parts, in the sea, in the air. Again and again, it makes brains. It accelerates learning in the lifetime of an individual, which is what a brain is for. And it makes those brains smarter over time. So there is a general drift towards increasing smartness. And then evolvability is another trend over time. The very process of evolution, as we understand it, has changed, has evolved. The first bacteria were evolving and changing in very rudimentary ways, very limited ways. And over time, as it became more complex and diverse and specialized, it could actually increase and change the ways in which they changed. And so when evolution invented recombinant sex, suddenly there was this powerful engine that could mutate and vary and change in ways that it could not before, and the whole system itself became more evolvable. So it was easier to evolve, and over time, the whole evolvability of the system kept increasing. And so we see over time that the speed and range of evolution and the very process by which evolution works has been evolving itself. Exotropy is just a word for order. We see increasing order, and that actually, as I'll explain later on, began even before life began, but that's also something we see increasing. Structure, increasing ways to structure, different ways to alter those structures, and then meta levels of structure. So these are some of the general, and not all of them, there's more, but these are just some of the sample long-term trends that we see in evolution, that runs through evolution, that seems to be pushing and biasing the general direction of where life is going. We can see that same thing happening in the technium. This almost looks like those butterflies. These are smokestacks from locomotives about 100 years ago, spark catchers, and lined up they look like mutations and little variations on them in much the same way that we would find in the biological world. And then we see in specialization the fact that the first hammer was a general purpose hammer, like the one I showed you. It was used for everything, but over time we invented more specialized versions of it. And nowadays it's true about high tech. We can have a camera, and the first cameras were used for everything, whatever purpose you want, and then over time we developed more specialized cameras, and so we had the underwater camera and the panoramic camera and the infrared camera. And then over time we made more specialized versions of those, and so we made the underwater infrared camera and the high-speed ultraviolet camera, and then we made more specialized versions of the underwater panoramic infrared underwater camera. And so those specializations will continually happen in the technium. And we can actually kind of map them out almost in the same way that we would map out the kind of permutations in a living tree. And so these are medieval helmets and showing their paths of development. And it resembles the clades in life. And I think the more we look at how innovation progresses through the technium, the more it resembles what happens in evolution as a system, so much so that I think we can actually take the 6 kingdoms of life, the canonical 6 kingdoms, plants, animals, fungi, and 3 different categories of bacteria, and we can actually append and say actually that the technium is sort of the 7th kingdom of life that's arising out of the mammals and the primates, and that it's extending the very same forces that animated the biological organic world. And so if that's true, then we'll say, well, what technology wants, what the 7th kingdom wants, is basically what life wants, what the other 6 kingdoms want, what evolution wants. It's the same things. It's complex, increasing complexity, increasing diversity, increasing specialization, mutualism. So that when we want to look at and say in a large scale, at the macro form, with broad strokes, if we want to see where is technology going, I think the answer is going to be, as we look into the future, we can say technology is going to become more complex. It's very, very rarely will it ever become simpler. Anybody hoping that things will become simpler is going to be vastly disappointed, because that's not the direction it's going. There'll be increased diversity of things that we make, and we can map that out looking at barcodes and SKUs, where we can show that the number and variety of things that we're making is continually increasing and will increase in the future. Increased specialization, of course. You can take any artifact that we make today, any invention, and you can make a pretty sure bet that in the future there'll be more specialized versions of it. That's the nature of the way things go. Mutualism is the same thing. Our technology becomes more and more codependent upon other technologies, requiring more and more. New technologies will require more and more supporting and scaffolding technologies to be made and then to work. And at the same time, these technologies also allow us to become more social, and making the environment, the entire environment, more codependent. And so I think we can say the same things about ubiquity, which is obvious, and sentience. We're obviously we're making everything smarter. We're putting little slivers of intelligence, little tiny chips, smart as ants, into everything that we make. And I literally mean, in the goodness of time, everything. We will put that sliver in manufactured goods, canned goods, clothing, shoes, sports equipment, everything. We're like evolution, which constantly reinvented and put sentience into all kinds of life. We're putting it into everything that we make, and of course the smartness is increasing. We're making the smart things, we're making dumb things smarter and smart things smarter. And so that's a long-term trend, and if you want to look at where things are going, you can imagine everything becoming a little bit more sentience. And evolvability, of course. What else is the technology really about, but other than accelerating how things change? So we're changing the ways in which things change. That's the big event, where the very nature of what we understand as change is changing. The whole system is constantly being, the rules are changing. The rules of change are changing. And so this kind of large-scale disruption comes from the fact that the whole system is becoming more evolvable. You can think of just something as simple as the scientific method, which is the foundation of a lot of change in the world today. The scientific method itself is evolving. Some of the concepts that we think of as the scientific method were only invented in the last 70 years. So like the placebo, like the double-blind experiment, things that we think of as that's the scientific method, are very, very recent, which means that the scientific method itself has not stopped evolving. There'll be more change in the scientific method in the next 50 years than there were in the last 400 years. So the very process by which we discover and make and invent, all those things are changing. And so the evolvability of the entire technium is increasing over time. And exotropy, as I said before, is this long-term trend in self-ordering, which I'll return to later. But that's, again, that's not all the trends, but those are some sample trends that are present in the technium that are moving us in this direction. But the thing we have to understand about this is that I don't want to, all those things are good, but I don't want to suggest that this is kind of a utopia. I mean, this is not like we're moving to utopia. We're just moving in these directions, all of which are good. But like biological evolution, I mean, I don't know if people think of that as utopia. That's kind of like there's a lot of death there. Lots of things die all the time. Things go extinct naturally. I mean, it's not utopia. It's good. Life is good. More life is better. But it has problems. And one of the things we know about when we invent something is that often, each time we invent something, we invent new solutions as well as new problems. New problems come along. And actually, I would even go a little further and say that, in fact, most of the problems we have today are technogenic. That is, that they have been created by technology. And I would even go further and say that most of the problems in the future are going to be created by technologies that we have today. So technologies create almost as many problems as they bring solutions. That means that the stuff that you make, your designs, will create problems. Okay? And so the question is, well, what do we do with those problems, or what does it mean? And because they create almost as many problems as solutions, there's a tendency to say, well, that's a wash. I mean, that technology is neutral. That's a very common belief. Technology is neutral, and we can use it for good and bad. And there is that's true. I mean, that's true that we can use it for good and bad. But I don't think it's neutral because I think that's an incomplete accounting. I think there's another calculus going on that we need to address. And that is that when I invented that, when we invented the stone hammer, when we make something new now, but even in the past, the persons or people who invented the hammer, they could use that for killing someone, or they could use that for building a house. That was a choice they had. They had kind of a choice for ill, to decrease choices or to increase choices. But what's important is that that invention gave them that choice, gave them that new choice which they didn't have before. And every invention will create at least one new choice, but often many more new choices that did not exist. And those new choices, even when they're used to constrain other choices, that choice itself is good. Okay, so that little choice, those additional choices, tip the balance slightly in favor of the good, even if the overall thing is producing as many problems as solutions. And that 1% turns out to be important because because 1% may be all that we need. I mean, even if the total sum is just a little bit more good than harmful, 1% compounded every year over centuries is a lot. So if we can create 1% more than we destroy every year, or even 0.1% more than we destroy, 1% compounded over centuries gives us civilization. So the delta doesn't have to be much. And I don't think actually the civilization is built on a very large delta. But that's all we need. And so I think that what happens was that with these technologies, we increase our choices. That choice that we have for harm or for ill is a tiny choice that tips the balance towards the good. That tiny bit of good gives it a moral summation over time. And that's where I think the positive nature of technology comes from. So, but we still have this problem of what to do with the bad stuff, the technologies that are harmful. And I think the answer to that actually think is understanding them as ideas. So if I was to stand here and give you a stupid idea, I don't think anybody here would counsel me to stop thinking or to think less. Because the proper response to a bad idea is not no ideas, it's better ideas. Okay, we come up with a better idea. And I think the same thing about technology, which is really kind of an idea made concrete. Again, it's an informational-based thing behind it. The proper response to bad technology is not to say less technology, no technology. It's to say better technology. Okay? So I want to say that again. So the proper response to technology that's harmful, that causes problems, is not less technology. It's not no technology. It's not to stop technology. It's actually to propose and make better technology. Okay? So that's the rhythm. Of course, that better technology itself is going to produce new problems. And the response to those new problems is not less technology. It's, again, better technology. And so we have this sort of escalating cycle of us responding to previous problems by technology with more technology, which may seem like crazy, but what it does is it gives us these increasing choices and possibilities. And so that's true even for the fact that there's no doubt that a lot of technology that we've invented so far in the last 100 years has been very harmful to other species in the environment. So the proper response is not less technology. It's not to stop that technology. It's actually to make it better, to make it greener, more compatible with life. And we can do that because actually what we've discovered, to my knowledge so far, there's not been a single technology that we've invented that we've not been able to make a greener version of. Okay. which means that the technium itself is not inherently anti-life. It's actually compatible with life because we can always make it more compatible, which would make sense if it's the seventh kingdom of life. It's an extension of the life forces, and so it must inherently be compatible and not antagonistic to the environment. So again, and we get there not by doing less technology, not by doing no technology, not by stopping, but by doing more, by making it better. And I think, in fact, I think technology is, in some senses, is, again, it requires this network of related technologies, okay? It requires some field, some ecosystem of technologies, and often what we want to do is we want to relocate technologies and give them better friends, better jobs. An example of that would be DDT. That's a molecule we invented. It's a technology that we devised for pesticides, and it was sprayed into millions of gallons and millions of acres as an industrial agricultural pesticide for cotton and other crops, and it was a total environmental disaster. We take the same molecule, relocate it, give it a different network of related technologies, and used judiciously sprayed around households in the tropics. It's the most effective malaria control that we know of, saving hundreds of millions of lives a year. That's the proper response to something that's harmful, is not to ban it, but to reimagine it, to relocate it, to make a more convivial form of it. So what does technology want? I could compress that longer list of increasing diversity, specialization, and stuff into another list, which is maybe a little bit more understandable, and that is that what technology wants is really this: increasing differences, increasing diversity, increasing options, increasing choices, opportunities, possibilities, degrees of freedoms. That's what we get. That's what we get when you're working and making new things. That's the large-scale benefit that we get by inventing things. So in the end, despite the problems and the trade-offs, what we're getting when we invent things is new choices and possibilities, and these are all good. This is what life brings us. And so the reason why that's good is that it's also good for us, not just for the world, but for us. And in this way, everybody here has a different mix of genes, therefore, and you have different faces and different talents, different skill sets, different geniuses that are waiting for, I think, often the right tool to help us release and express that. And if you can imagine that Mozart needed the harpsichord or the piano to shine, to have his genius be shared. But imagine if Mozart had been born 2,000 years before we had invented harpsichords, pianos, or the symphony. What a hole in his life and our culture that would have been if he had been born 2,000 years before those technologies, or Beethoven, or anybody else like that, or if Van Gogh had been born 1,000 years before we had invented the technologies of oil paint and canvas. What a loss that would have been to him and to us. And we have likewise, if we had not invented the technologies of cinema for Hitchcock or Lucas, and they had been born 1,000 years before them, what a loss to them, to us it would have been. But by that logic, it means that there is somewhere in the world today, a boy or girl, some Shakespeare of their generation, who's waiting for us to invent their tools, who's waiting for us to provide them those possibilities, those technological things that will help them see and express and share their genius. And what a loss that would be if we don't do that. So I believe that we have an obligation to create things, to make new stuff, to make new tools and possibilities for them and for future generations, just as we've benefited from the people before us who invented the possibilities of, say, writing and printing and the book for me, and maybe computers and programming, or the camera. All these possibilities that previous generations have made, we have an obligation to increase that so that there's a chance that every person born out and in the future would have a greater opportunity to find that no guarantee, but they have a greater opportunity to find those technologies that they would need to express their genius and share it with us all. And I think that's what, again, what we're doing when we're making these things and we're inventing it. We are often consumed with the idea that, you know, maybe we're addicted to novelty. Maybe people are just doing this to make money. We're making new things just because of some kind of a capitalist racket. We're making this to feed the consumerist engine. Or we're doing it because we have nothing else to do. Those all may be true, but we're also doing it because while we do it, we're increasing the possibilities, choices, differences, diversity of the world and for others. But even more importantly, I think there's even another story, and that is that, as I said before, that exotropic trend runs through life and runs through the technium. And what that is this self-organization, this self-organization increasing diversity that we see, actually preceded even life. It began at the Big Bang. The Big Bang was this instant, whatever it was, some creation that was completely uniform, and very quickly, over time, it started to specialize. It started to make multiple different kinds of atoms, and it made all the things that we know. They fell out in an unfolded way, and we saw them self-organize into these large structures called suns and stars and galaxies, and these are billion-year structures that increase in order over time. They get more and more complicated, and they revolve, and they self-organize over billions of years, and they self-organize the atoms into stars. And those stars are actually machines or furnaces, however you want to think about them, that persist for billions of years that create heavier atoms from lighter atoms. So the hydrogen and heliums are turned into heavier atoms. They may go through several cycles until they become as heavy as iron and heavier. And then those heavier atoms self-organize into planets. Those planets may self-organize an atmosphere here and there, at least our planet did. That self-organized atmosphere can produce self-organized life. That self-organized life can actually produce the self-organization called a mind, and that mind can self-organize the ideas for the technium. So in a certain sense, this increasing complexity, increasing diversity, increasing specialization, all these factors are actually at work even before life. They began at the Big Bang. And we can say in a certain sense that this is a self-organization trend, this exotropy, that runs through the cosmos, the bios, and the technos, where the technium is sort of just the latest acceleration of the same process that began long ago. Okay, and so what I want to leave you with is this idea that, in fact, when we are making things and engaged in this, it's not only an extension of life, but it actually is an extension of something that goes even further back. It's a part of a bigger story. There's something much bigger than ourselves. And I think that it's this long arc, again, not headed to a destination, but it's a long arc in which there is a longer story of increasing self-organization and possibilities, options, and opportunities, starting with something very small and increasing in all those directions. It's a direction, not a destiny, and that this increase in possibilities that we see running through the universe is something that we can align ourselves with as we make stuff. It's not just about making money, not just about being addicted to novelty. We are actually becoming part of something bigger as we do these things, as we increase the possibilities for others, as we make the possible tools for people in the world to have a chance to express themselves, that we are doing something good. And that's what we are involved with while we make and invent and design new things. So I hope that helps give a perspective what I believe that you're training yourselves to do. And I really would love to have a conversation about these ideas and places that you may not understand or disagree. But thank you for your attention.
We're going to open up to questions, but I'd like to start with the first question. I'd like to know a little bit more about the long now.
Yes. Okay. So, as you can see, I take a long perspective. I'm suggesting that we, in our culture right now, emphasizes next quarter, next year, the next 5 minutes, what's hot, what's new, what's on Twitter. And I think there's a real value in trying to take a longer view, and particularly when you try to do big things, because there's many big things that we should be doing, global climate adjustment, all kinds of things that may not be able to be accomplished in 5 minutes or 1 year or 10 years. They actually may take generations. And we don't really have a very good either mechanisms, institutions, or perspective to even think about generational projects or generational view. The Long Now Foundation was started from a bunch of people who wanted to foster long-term thinking, taking the long view of both in the past and in the future, suggesting that a great civilization is one that actually thinks at civilization scale, thinking about 1 or 2 generations ahead. And as part of that, as an emblem, as an icon, we are building a clock that will tick for 10,000 years. Okay? Now, this is talking about a design challenge. This was really very difficult because one of the main problems with 10,000 years is that almost anything you can imagine if it's trying to move over 10,000 years will corrode, get corrupted, or if it's not moving for very long periods, it can fuse. There's issues about if it's really valuable material in 10,000 years, it will be stolen sooner or later. How does it powered? How does it get repaired? And where is it? And so we came up with some solutions that were kind of cool. The current version is a clock that is actually a mechanical digital computer. So it's like made out of metal. There's no electricity. It's actually calculating time in moving little bits of metal around rather than gears. That reduces the number of moving parts. It's powered by the changes in the day and night temperature. But that only tells the clock what time it is. It doesn't display the time. To see what time it is, you have to actually visit the clock and add your own energy, wind it up, because it only shows the correct time from the last time it was visited. And so it knows the time, but it won't tell it to you unless you give it some energy. It's inside a mountain. It's 400 feet high, the tunnel. There will be a stone spiral staircase. And right now the first one's being built in Texas. We're going to build a bigger one inside a mountain in the national park in Great Basin, Nevada. The purpose of the clock is, once the clock is there, then you start to say, well, what can we do with, it forces people to think about 10,000 years, which is about the age of civilization. Civilization is about 10,000 years old, so we're kind of like in the we're saying, well, 10,000 years in the future would put us right in the midpoint. And so what could we do? What do we want to do with 10,000 years? How do we make use of that? How do we, in some ways, take a longer perspective? And that's the function of this organization. We have monthly meetings and talks about thinking in long term. We don't have any, it's not like the Asimov Foundation where you're kind of planning the next 10,000 years and we have the whole thing in our minds and we're going to unravel it. We're agnostic about what it is. We're just saying we want to provide tools and inspiration for people to make their own version of generational plans. And we're trying to say, well, how would you, whatever your proposed project for 1,000 years or 100 years, how would you go about it? And we want to look at what kind of tools you would need to be able to do that. So that's DeLong Now, and we're in San Francisco. You're welcome to come to some of our talks or participate in some of the other projects. We did a backup of languages. It's now on a comet. It's on a probe going to land on a comet which will circle the solar system, and there's a backup of 1,000 languages, 1,000 human languages. We figured you need a backup. So we looked at time capsules. Actually, we looked at time capsules, and we decided that we didn't. You don't need a time capsule because our garbage dumps are better time capsules than you can make. You always forget to put something in a time capsule, but the garbage dumps have everything. So So other questions? Right here in the front row, yes?
I have a question, actually more clarification when
Yeah.
you talk about complexity.
Sure.
You were saying that everything is going to be more complex than its predecessor.
On average, okay, it's very rare, but on average, yes, there are exceptions.
I guess the question I have is how you define complexity and in what context. You have argued that, for example, the smartphone is more complex because it's connected to more networks and the cloud or whatever. But from a human interaction standpoint, things tend to be getting simpler and
Yeah,
simpler.
the interface certainly. We can think of the egg, a chicken egg. What could be more simple than that ovoid? Inside, it's incredibly complex, and so the iPod is a nice, simple interface, but inside, it's actually getting more and more complex. So yeah, I'm not counting the interface outsideness. I don't really count that in terms of it. Obviously, it makes a huge difference to humans, and yes, I think we can certainly. I can imagine future technologies being a round black sphere. Who knows what it does? But inside, it's going to be incredibly complex, and it'll actually, but importantly, it will require many other technologies to support it, and maybe even complex behaviors to really fully appreciate it. So here's an interesting thing. I mean, one of the issues that people have with this exploding possibility space is that we all feel the fact that the choices can be overwhelming. That in fact, one of the problems that technology is making is choices itself, that the abundance of choices is actually a problem. And I'm going to revert back to what I was saying before. So one solution that people think about is like there's all these choices. How can we deal with these choices? Imagine what kind of choices we'll have in 100 years from now. And therefore that we should move back and have less choices and less technology. And I'm actually going to suggest something counterintuitive, which is I think that the solution to the problem of too many choices in technology is better technology. And so here's one example where we've already done that. This is the invention of technology called the default. The default is a technology that basically kind of hides our choices until we want them, until we're ready for them. So there's all these choices in some new device that you've made or making. And rather than be overwhelmed by all these choices, we're gonna hide them in a default. And then when you want those choices, you tell it, show me all these other choices that you were hiding. And so it's a way of kind of compressing all these choices into it. That's a very simple, rudimentary, very primitive technology that is a solution to too many choices. And there may be hundreds of others that we could invent that would allow us to deal with these choices and also the speed of those things. And so I think the answer is not less choices, but better choices.
So when you refer to the hammer, that specialization, you could see it as adding more complexity, but in fact, from an interface standpoint, it's making it easier to use for a specific task. So in a sense, it's simpler.
Say that again one more time.
Well, if you're talking about the diversity or the evolution of a tool, a fork or a hammer or whatever, it's more complex because we have more choices. But in fact, for doing a specific kind of task, it might actually be simpler, as opposed to having the one-size-fits-all stone mallet that we can use, for tiny little things, or for big things, or for filling, or for making.
So you're saying that sometimes complexity makes things simpler?
That's
yeah.
a question I'm asking.
Yeah,
it makes the action simpler.
Yeah, that's possible. And also, I have to say that one of the choices that we often have is a choice of multifunctional. So in those knives, we have the knife, and then we have the Swiss Army knife, which is like all the knives together. So one of your choices is like all of the above. And I think that's, in other words, one of the choices can be the general purpose choice. So, yes, Brenda. I think we have a microphone for...
There seems to be some compelling evidence that species other than humans make tools.
Yes, absolutely.
And so I wonder if the attributes that you've given to the technium,
Yeah.
apply to, say, crow-made
Yeah.
tools?
Yeah, in fact, I would suggest that the technium sort of erupted in very small proto ways in beaver nests, birds' nests, which are kind of weaving, they're indistinguishable from early human weaving. Beaver dams, termite, skyscrapers. These are definitely extended outside the body, and they come from little tiny mines, and so I think they're part of this technium. So the technium, again, is I don't think a technium is a very human thing. We identify it as very human, but it kind of precedes us and it's going to extend beyond us. And it's a force that I think is going to come from wherever there's minds who can manipulate and make these information flows.
Thank you.
So in the back I see a hand there, but I don't, or in the middle, the guy with the glasses, right there, yeah, that row.
Thanks for coming.
Sure.
One thing that I'm curious about, I don't see a harmony with what technology is advancing itself with sustainability. Right? Technology wants and wants and wants, but it doesn't seem like it's sustainable, and we're going to get to a point, this tipping point, you talk about green. Green's
Right.
good, but we might be past the point where green's
Yeah.
going to do any good anymore.
Right.
Where's the sustainability for technology to go forward if there's no harmony with where it's getting its resources?
Right. So one thing that we might want to aware of is that there's no harmony in nature. The idea that there's harmony in nature is a kind of an urban myth. There's no harmony. It's constantly changing. Whatever, you go look at whatever biome or scene that you want to, and that's not how it was even a few thousand years ago. It's complete dynamic. Things are always moving around. Ecosystems are incredibly dynamic. There's no harmony at all. But I understand what you're saying. You're saying, is it possible to even think about the future of technology if an environment on Earth doesn't survive? And I think it's a legitimate concern. And I think we absolutely have to do it. There's no guarantee. I mean, we could be making really bad decisions. Every technology that we invented, we can weaponize any technology. So what I want to be clear about is that there's the general form of the technology, then there's our expression of it. So we can take any technology and weaponize it, which is basically to decrease choices and options. That's what weaponizing, that's what killing people is you eliminate those possibilities. So we can weaponize anything. We can go in the other direction. We can, I don't know what, peacify anything, if you want to call it. So we can make it more convivial, and so we certainly have that. We certainly have that chore in front of us to make sure and to choose those versions, those expressions of technology that are more compatible with nature. All I'm saying is that it's not the technium's fault. It's not inherently impossible. We can do it. We have to do it. Is there any guarantee we will? No. But it's not inherent in the technium itself to go in that direction. So I think that is a challenge we have. And do we have any guarantee? No. But I think that's what we should be working for. I'm going to, this fellow, yeah, right there. Yes, please.
You mentioned that as things get more complex, they're getting better. And when I think about nature, I don't really. It seems like nature doesn't actually have a purpose, that it evolves and evolves and evolves, but I don't know if there's, that it's actually getting better. And if you look at man, it seems like nature was doing fine until man came along, and now it's sort of self-destructive. And I'm wondering if technology, if increasing complexity is really better. I guess that's my question, is increasing complexity better?
I think increasing complexity is good because it brings increasing options. So here's the thing. Do we think life is neutral? Is life neutral? Is thinking neutral? We would say life is good, more life is better. Why do we say that? What is it about life that's so good? Well, yeah, exactly, because the alternative is death, which is decreasing possibilities and choices and options. And so is complexity better? The complexity itself is not better. what is better are the new choices and possibilities that it brings. So, you know, if in other words, I think there's a lot of again, I don't think we should think about life itself or evolution itself as sort of utopian. And by better, I don't mean this utopian world. But I think, in fact, that if we lived on a kind of a ball-bearing planet with nothing, no living anything, and we were somehow, I know, exempted from that, but there was nothing else but us. And there was a busload of, someone's coming with a spaceship, and on it was all this life, seeds and stuff. And someone was coming in, and we would say, wait, what do you got there? And we go, well, we got this self-replicating stuff. It's just going to grow at random, and it's going to mutate, and it's out of our control, and who knows what's going to happen, but it's like there, and it will kill each other. It's like, we would say, no way. That's illegal. Where's the EPA? How do we know that that's not going to be harmful? Maybe some of that stuff might kill us. Basically, we would not tolerate that kind of uncertainty, that kind of... So I'm saying life as a system is really as unsatisfactory to us as the technium is, in some senses, okay? It's just that we're used to it. We don't understand how it works, it's, you know, but we're going to use it. And so I think I'm suggesting that the technium is very much like life in that way, that we understand that it's good, that all those differences, all those ways in which it creates possibilities is what everything in life that we find good basically has those elements in it. And so it's not the complexity itself that is good. It's just that the system itself is breeding these possibilities, and that's what is good. So in the middle, there's a gal there with a sweater, right? Could you wait 1 second? Because I think they want to pass you a microphone.
It seems like the conversation could benefit from talking about the difference between complexity and something that's complicated.
Yeah.
I think you can explain that better than
Yeah. You know, that's a really good point, and I wish I could be more explicit, but here's a really interesting thing, and that is that we don't have, we, meaning science, not me personally, but science does not have an operational definition of complexity. We all intuitively have some sense of what that is. But when you actually try to have a definition that could, say, measure whether a cucumber, which is more complex, a cucumber or a Boeing 747, the answer is we don't know. And that's because we actually don't even know what information really is at its foundation. We have some ideas, but we don't know the larger idea. And so I think what my definition of complexity would be something that had increased levels of order and increased relationships among the bits. And that's a probably unsatisfactory answer, but what I would suggest is that there was multiple levels of being, in the same way that, again, going from like a beehive to a bee. There's the bees and then the hive, and they exist at a kind of a hierarchical level. Both of them are there, but there's two levels of existence, two levels of order. And so we see in complex things that they have multiple levels of meaning. We don't have mathematical language to really precisely define that. Maybe someone here will be the genius that will solve that. But in the meantime, we use this idea of things that seem complicated to us, but complicated in an orderly way. So I'd like to get some more students.
When we're developing
Yeah.
something or designing something, how can we decide what's better in regards to the long term?
Yeah. So how can we decide what's better in regards to low now? How can we evaluate? So that's a really good question. I don't think we have a lot of good tools, but I think for myself, just asking that question is alone, we would consider that a success, right? I mean, that's all we're sort of asking, is just ask that question. how, what's the long-term consequences, or how could this engender other people to think long-term? What would future generations think? What are the unforeseen consequences of this over the long term? And I think that is really all we're asking. We don't really have an answer to those questions. We don't want to have an answer to those questions. But we want people to ask those questions and to think about them. In fact, that's sort of the joke in the long now about the clock, is that when people start to see the clock and they say, 10,000 years, why 10,000 years? Already we've got you. And that's the whole purpose. So way in the back up there, yeah.
Yes. Would you argue that we created technology, or that technology created us?
Good question. Okay.
And are we as human beings technology?
Yes. So the answer to the last one is yes. So here's how this goes. Actually, I believe that we are the first domesticated animal. We're the first animal that we domesticated was ourselves. We have invented our humanity, and we are still inventing ourselves. We're not done yet. And let me give you an example of that and why this is important. One of our first inventions was this thing called cooking. And cooking is actually an extended stomach. It's a way for us to digest foods that we could not biologically digest. And that cooking thing, that extended external stomach, actually, that nutrition that we got from that changed our bodies physiologically, genetically. So our teeth shrunk, our jaws shifted, our enzymes were modified, and over the long term, of course, and we have some belief that that actually might have accelerated the growth of our brains and other kinds of things, but also, in addition to over the long term, we became wholly dependent on this technology of cooking for long-term fertility. So the moment when we, the days basically when we were independent of technology have long gone, tens of thousands of years ago. We have been wholly dependent on technology for 10,000 years at least, 50,000 years. And so we are becoming ever more dependent as we go along. So what does this mean? I mean, there's lots of examples, even with like domesticating milk-producing animals. We evolved lactose tolerance, and in fact, our genes are now evolving 100 times faster than they were 10,000 years ago. So rather than cultural evolution taking off the pressure of biological evolution, which is what many people thought, it actually turns out that it's accelerating biological evolution. So we are changing ourselves now faster than before. What does that mean? That means one important thing, which is that we are the creators of the technium, and we are the created. We are both, we're playing both sides. We are the created and the created. We are the self-created. And that means that we are both the masters of the technium and the servants of the technium. And that tension is fundamental, and it's very hard to unravel, and it will be there as long as technology is around. So in 1,000 years from now, we'll still be wrestling with this tension of the fact that we are in command to some extent of the technium, and yet it commands us. Okay, we are the created and the creator. And I think, you know, as it goes back, this good news, bad news. Technium has its own agenda, it's selfish. What it serves us is amazing. And so we feel that tension, and I think we're always going to be wrestling with the fact that we are part of it. We are symbiotic. The technium includes us. And that's just, you know, that's where we are. So over on the side, we haven't got anybody there. Yes?
Okay, you were talking about like better technology, about like the need that like there's obviously problems to have better technology. I guess what I'm kind of interested in is like for like everything that's invented, there's like you know 200 people that thought of the idea,
yes,
that rushed to the patent office, or
right,
you know whatever. So how can we, instead of just better technology, how is there better sharing of the ideas to make the technology go quicker?
Yeah, no, actually this is an important point that actually most innovations are simultaneously independently discovered. That's actually the norm. That's one of the reasons why we can kind of understand that there's kind of inevitabilities in technology. But you're asking how can we actually accelerate this sharing. And I think this is actually one of the major things happening right now. I mean, I think one of the exciting things going on in our world right now is this, that we have these new technologies that allow us to have relationships and sharing in dimensions we could not have before. So we're exploring this new territory of intimate sharing in new dimensions. Before, you had to be adjacent to someone else to really share with them very much. Now we're finding out that we can have ways of sharing where people are not adjacent, they're only adjacent conceptually. And and I think we're just at the beginning of actually learning what and how we share, and involving the technologies of sharing and the economics of sharing. And so on the sharing meter, I think we're still down like a 1 or 2. And what's interesting is that every time people say that people are not going to share X, it turns out that they're wrong. People will share X. And we understand that actually the benefits of sharing are so great that we're constantly being surprised by what can be shared. And I think that some of the things that we've made with this process, like Wikipedia, are actually stupendous. And I think the most powerful thing about the Wikipedia is that it has proven to us to believe in the impossible, okay? Because it was impossible. Every expert on human nature had declared that something like Wikipedia was impossible, but there it is. And I think that is sort of like become like an icon almost, like you know, where it sort of inspires us to also believe that other things with a similar kind of sharing might be possible, and to suggest that in fact we've only begun to understand really the many ways in which we can relate to each other in the many new dimensions and do things that we thought were impossible before. So I think this is an incredibly exciting time, because I think we've just begun to explore those things. So I'm getting conflicting signals. Do you? Okay, so the guy in a white shirt, and then there's a woman behind there. Yes, good. The white shirt. Okay, go ahead.
So between when you're faced with a choice between compromising on the present and the long term,
yeah.
What do you do?
Yeah. No, it's one of the things is that there's a term called discounting the future, which is human psychology, where we tend to if I'm going to reward you now, that could be very valuable. If I take the same reward and I'm going to reward you in 30 years, you discount that. You say that's not as valuable. And so that's part of the problem, because sometimes that may be a future generation where we'll derive no benefit whatsoever. And I think it requires a certain, I don't know, evolution of our spirit, an increased expansion of our empathy to actually start to think about that kind of delayed gratification and a way of actually not discounting the future. So right now, that calculus that we go through is very difficult, and it biases towards doing things now. And I think that we have to be trained in a certain sense to work out a different calculus. And I think we can do that. I think lots of things that our civilization has done are things that don't come naturally. And so, you know, being kind to someone outside of your clan, that does not come naturally. That's something that we actually have to train. That's something that we have taught ourselves to do. That's part of the technium. And I think some of these other things, like taking a longer-term view, may be things that we have to actually train ourselves to do. Because right now, that calculus, you're right, it doesn't work out very good. So the woman behind there, yes, please. Okay.
All right. I was just curious. You know, this isn't a challenge with your philosophy. Just simply your model of the arc. I guess I see it as more of an ellipse. You know, it's why you overlay it on a model of the or an image of the universe. You know, and why would it be just an arc to nowhere? You know, why isn't there no entropy in your model like in most other things in the universe? I don't think it changes your outlook on technology. But
so actually, entropy is at work. There's the entropy, which is, by the way, is this the rule that everything is running down, that the universe, that there's a drift, a sinking towards heat death. Every action creates waste heat, and that waste heat uses up a little bit of the order, and we see this kind of slide down to an even bottom. That's the only law we know about in physics that we find no exceptions to. And so there's entropy. So the whole world's sliding down to it's kind of like what Woody Allen says. You know, he went to the psychiatrist because he was depressed because the universe was running down, and he thought it was. I mean, we should be depressed by that. But what these exotropic systems do is they actually create order temporarily in this sort of long thread by accelerating the creation of entropy locally. So that's why I put it as a narrative, because in fact every system that we have, like life, is actually sitting upon a long sequence of other systems that temporarily create order at the expense of creating more disorder around it. And so it is like a journey going through. And entropy is where everything else is headed, except for these little pockets or threads of self-order, which keep going and create additional disorder in order to keep afloat. So I guess there's a natural lull in the energy. I appreciate your great attention. Thanks for the great questions.
Thanks everyone for coming. There's food outside. If you have a book that you want Kevin to sign, he'll stick around and sign it for you.